Okay. You see my hips? See my hips? You swing right through, nice and easy. All right, come on. You give it a try.
It's just a ride to the airport. This wasn't exactly what I had in mind when I said I owed you one.
Hey, you act like this is torture. You know, there are people who think this is fun.
You know, believe it or not, most of my childhood sports memories aren't altogether pleasant.
Reed, it's just one game. We need a body. You might not even have to play.
Perfect. Can we go now?
Reed, just humor me, take the bat, and get up there and give it a try. Get up there. You're gonna like this, kid, I promise. See it and hit it. Just relax. Here we go. Okay. First try. Keep your eye on the ball.
Gravity plus drag coefficient plus magnitude. I see what you're saying. If I can adjust the velocity of my swing.
No, what I'm saying is get out of your head. Just feel it.
Feel it. Feel it.
Don't think. Just feel it.
Just feel. Don't think. Just feel it.
Here it comes. Reed, that's not feeling it.
I'm feeling like an idiot.
All right, so in case you didn't catch what Reed said, he was talking about the force of the bat due to acceleration. Well, acceleration due to force, as he swung the bat to try to hit the ball. Now, according to the book, which I have right here, so be happy with me, that to determine how force, acceleration, velocity are rating, you need to be able to exert a constant controlled force on an object. Now, he couldn't hit the ball, unlike Morgan, as we saw force being acted on upon the baseball. Morgan hit it, and we saw the distance it went. Now, Reed, he kept complaining because his acceleration and force and velocity wasn't great enough, so he couldn't get it to work. Now, there are many ways to help fix this. As Morgan said, just get out of your head. But, also, back to the book, how does this acceleration depend on force? You need to figure out how acceleration depends on force. Well, in the experiment they're talking about the current being pulled by the stretched rubber band. Now this works because you are pulling it, so there is force being exerted on the current, and it is accelerated because the rubber band can only have so much force put on it before it starts pulling back. Now, take a look at the clip again, second part of it, and tell me, do you think Reed finally understands the difference between force and acceleration? A stretched rubber band exerts a great force onto the current, as mentioned in the experiment in our book. Now, if you can see this in the bottom corner, it's like when I pass, this is showing a current being stretched by the rubber band. The rubber band pulling the current is forcing the current to move. It's forcing it to accelerate. Thus, acceleration equals force divided by mass. It is forcing it to accelerate. So this helps explain. Now, how does velocity tie into this? Well, that's actually easy to explain. The way that this works is that when you, as in the clip I showed you earlier, when Reed swung the bat, it was trying to accelerate a force. It was accelerating and picking up velocity. Now, he couldn't hit the bat, the ball.
Drive him in. Time out.
There you go. Come on.
Okay, listen to me, kid. Look at me. It is the bottom of the ninth. There's 2 outs, and we are losing by 1 run, okay? You are the guy, Reed. Yes, all you have to do is get it over their heads, and I will score, and then you run like hell.
Here's the thing. I've been doing the calculations. Force equals mass.
Reed, stop. Get out of your head. All the physics in the world will not work unless you just let it flow.
I don't know if I can.
You remember all those unpleasant childhood sports memories. Okay, right now, you can erase all of it for good. Kid, stop thinking. Just feel it. You got this, okay? You got this. Let's go.
Come on, pretty boy. He's the man. Take one. That's all right. Attaboy. Woo!
You gotta believe
You can drive him in. Come on, Spence. You can drive him in, baby. Come on.
Strike 2. This guy's got nothing.
the equation A equals F over M. This equation tells you that force applied to an object causes the object to experience a change and will cause the force will cause it to accelerate. So, A equals acceleration, F is force, and M is mass. Yes. So your acceleration is due to force divided by mass, which actually makes a lot of sense, as later stated in the chapter. The way that velocity ties into this little trio of velocity, acceleration, and force is that velocity works with acceleration. It's how much you're speeding up per second. Now, to understand how an object moves with all these forces worked upon it, it's actually pretty simple. One way, experiments. One way in this book it talks about is the cart being pulled by the stretch rubber band. It's just the best way to start is horizontally, not vertically, horizontally. Reason is because there's no natural horizontal forces being applied on it. You have ones from above and below, but you don't have ones from the side. So, by doing this, you can pull it, and there's that force that isn't normally exerted on it. So you can use that to explain how each and everything is exerted.